because it was rushed at the end of class, I'm just going to restart into A real quick and make sure we understand what we were talking about. Okay? Solving graphically, well, that means you get shortcut and you get to use the calculator, right? And we're going to look at a graph. In order to plug a graph into your calculator, it has to be in what form? It has to be y equals. Well, right now, if we have terms on both sides of the equation, it's not a y equals. And so to make it y equals, we want to move everything to one side. And do the book directions say to make it equal 0 on the right? Solve the equation graphically by converting it to an equation equivalent with 0 on the right-hand side, and then finding the x-intercepts. So, to get 0 on the right, we want to move the 3 square root of x plus 6. So, just think of that as one big term. How do you move a positive 3 square root of x plus 6? We're going to subtract. If I subtract on the right, we're going to subtract on the left. And so we're going to end up with the equation, absolute value of 2x minus 1 minus 3 times the square root of x plus 6, and then equals 0. So we've got that 0 on the right, and when you plug it into the equation, then you are plugging in y equals that whole thing. So if you haven't already done that, why don't you do that? Grab your calculators, and let's practice plugging this stuff in. Because, for instance, do you know how to do absolute value?
Where are the absolute values?
Okay, so one thing I will always say, there's a lot of shortcuts up with the alpha, but math. If you go into the math button, the math menu, pretty much everything you need is going to be in the math menu somewhere or another. But there's also a lot of shortcuts up top.
So,
No. Wait, maybe I did. I got it.
Number.
where's that?
I'm getting situated.
This is Python.
Absolutely. Yeah. Mine was still.
What is it?
Okay.
What is it?
Oh.
So, all the TIs, old or new, you have a math button right here. And this math menu, if you can't find something, it's somewhere here in the math menu. Now, right there, it's not in the math menu in that first column. I think you have to arrow over to num. If you arrow over to num, ABS stands for absolute value, and that will bring up absolute value bars. Now, I didn't go into y equals, so I need to go back out and go into y equals.
I didn't either. I'm so mad I missed it.
Okay, so I'm in y equals. You can go into the math menu and get it, or is it alpha F2 is your shortcut? Alpha, and I believe F2 brings up that menu right there, and that's your shortcut, so you don't have to go into the math menu. But if I just hit enter on ABS, it gives me absolute value bars. I can type inside of it 2x minus 1, then arrow to the outside, minus 3, square root of x plus 6. Now, you might want to turn your plot off if you haven't, which, remember, you can turn your plot off right here in this screen. My plot 1, plot 2, and plot 3 are all off because none of them are highlighted. And then to graph it, we can do a zoom 6. I'm going to do zoom 6 because I know I graphed weird things. Zoom 6 takes me to that standard screen. And does your graph look like my graph?
No, I don't have absolute value.
You have absolute value.
Is it the ABS?
Yeah.
Yep.
Oh my gosh.
That's what I thought. Like yours looks different. Yours have the lines.
It only has the lines after I type it in. Does yours come up with lines or no? Yeah, yours doesn't. I'll try to update yours later and see. I don't know if I can get it updated or not. But, okay, guys, here's the deal. We graphed it. Our job is to solve. Where are the solutions to this equation? Your zeros, your x-intercepts, yes? And we have a way on the calculator that we can find those, yes? So here's kind of your steps today. We set our equation equal to 0. We graphed y equals the equation. And then we're going to look for x-intercepts. What is the word on the calculator? X-intercepts are also called zeros. So we're going to find our zeros. How do we find zeros?
Second trace.
Second trace, second calc, right? It's that calc menu. So I always say second calc, second trace. It means the same thing. Use that to find your zeros. Okay. Are you finding it?
Yes.
Do you remember how to use this? Use the zero function. So I'm going to go second calc. I'm going to go to number 2, which is zeros. Now, I don't care which zero you find first. But if I try and find my left zero first. So if I try and find the one that's negative 2 something. To the left of it is past it. I'm going to hit enter. To the right of it is past it on the right side. I'm going to hit enter. And I'm going to backspace for guess. I'm going to put my cursor about on that x-intercept.
Thank you.
And one of your zeros is negative 2.361305.
Yep.
So I just put negative 2.36 is what I have in my calculator. These are approximates because I'm rounding. And then remember, you restart your process to find the second one, yes? This skill was on your test. So 0. Now I'm going to arrow all the way over to, I don't know, what is that, 5 or 6 something? Okay, left bound is before I get to it on the left. Right bound is after I go past it. The 0 or guess, I'm going to guess. 5.6113047.
Yep.
Or in other words, approximately 5.61.
Oh my gosh. Sorry. I was doing the next one. I'm just like, wait, who came on? Is it like a free rainbow? No. Whoa.
Okay, do we get it? We got it graphed?
Yeah.
We remember how to use zeros, yes?
Yes.
Okay. Do we go ahead and try B?
Let's just skip it.
Is that the graph for B? Is that what you were doing
Yes. I say we give it a shot.
there? Let's go ahead and do B, just because the graph is interesting looking.
I can't read, so I like this.
So, let's go ahead and do B. In order to do B, how do I make this equation equal to 0?
You subtract over x
Excellent.
plus 2.
There.
We have to subtract over x to negative 1, and we have to subtract over 2x. There's 2 terms, yes?
Yes. Oh, I subtracted over the other.
Maybe that's why you go.
It'll still work. Your graph is going to look a little reversed from ours.
Okay.
But officially, in the directions they say the graph or the 0 on the right. So I'm going to say we're going to subtract x negative 1 and subtract 2x. So if that's the case, I'm going to have x plus 2 to the negative 1 minus x to the negative 1 minus 2x equals 0. Do not try and do any cleanup here. It looks ugly, but that's fine because you get to just push the buttons and type it into the calculator, right?
Yay.
So I'm going to graph y equals x plus 2 to the negative 1 minus x to the negative 1 minus 2x.
Yeah, it looks weird.
So about this.
Okay, note, you're all having the same reaction, so we're all in the, parentheses, x plus 2, parentheses, raised to negative 1, minus x, raised to negative 1, minus 2x.
I love that there's like a whole button for just
Now,
the negative.
I don't know if you guys caught what I was doing. I think Kylie did there. But with the power, over on the left, you have a power for x negative 1 and x squared, yes?
Yes.
So you can just use those buttons to get that power. Now, if you have to do any other power, you have to use the caret button, right? So just kind of a little shortcut there. Okay, I took my other graph off. I've got this graph on. If you typed it in this way, your graph looks like this.
Not like too much.
But you're going to get the same answer.
Okay, yeah, it's
Can you
still.
imagine what the
You're going to get, okay. And so interestingly enough, I just want to give you a heads up. Officially, the book says to put 0 on the right, yes?
Yes.
Okay. So Sophie put 0 on the left.
You good?
And there's the difference of our graphs. Now, here's the deal. Sophie's still going to get the same answer. If you notice, we both have an x-intercept where? A little bit past negative 2?
Yeah.
So we're going to get the same answer. It reverses parts of the graphs. And so we have a very similar graph, it's just reversed. And actually, you know what? I'm going to do a zoom 6 on yours because it'll look even more similar if we're on the same screen.
I was on Zoom.
Yeah, you were zoomed in on, which is fine. But, so FYI, your graph should look like either mine or Sophie's, depending on which way, if you went with my equation, it looks like that.
Is it just flipped upside down?
Kind of.
I think so, yeah. I think it's just a reflection.
Yeah.
So, yes.
Mine doesn't look like either of those.
Okay.
Then go back to your typing and check what you typed in.
I'm so the same.
I'm going to disagree. It's probably not the same. Or you weren't zoomed in the same. X plus 2 to the negative 1 minus x to the negative 1 plus 2.
Sophie, can I see your graph?
Oh, you know what? Let's try.
It's plus 2.
Yeah, at the top.
Did you?
Plus.
Oh, I didn't even catch that. Yeah, it would be minus 2x. So
I was gonna say it looks similar. It's just
it is, which is why
down.
in my graph
Mine was
dark.
going up.
Yeah. Okay, there's my graph. So for comparison. Okay, are we getting it? Now, did you guys go find your answer?
Yes.
Second calc, 0.
Oh, there I am.
Oh my gosh.
Now, when you do this, left bound. I have to get over to that piece of the graph. Okay, my left bound is going to be up there on that curve.
Yeah.
Enter. Right bound is going to be down below somewhere. Yes, I'm going back. I can't get very specific.
There we go. I did.
Do you have a matching answer to me?
I do.
Negative 2.205569.
Yes.
So I'm going to say negative 2.21.
Yes.
Okay. The last one, and I don't know if I need to do both of these necessarily, but while I'm here, we'll just change the lesson names for the week, These two go along with, I think it's number 51. And you'll notice the title says, Seeing grapher failure and not seeing hidden behavior. And what it just comes down to is sometimes you really have to zoom into the graph or really look carefully to figure out what is there. Okay? Now, good news on A. This is already set up, yes? So you can go ahead and put it into your calculator. Three minus, now, if you can do a fraction bar, that's your best bet here. 1 over the square root of x squared minus 1.
That's count.
Okay? You have like two little plateaus. I don't know what else to call them there, but
Clips.
clips.
Yeah.
Got two little clips there. Maybe there's a river down between them. Okay.
Valley.
Now, as we look at this one, guys, this is A. I don't know. I don't remember. So if we try and find zeros, does it work? I'm not sure it will work, honestly. Did it work for you? Okay. Because here's the deal, guys. If I hit trace right now, it always comes up x equals 0. Notice there's no y value. If I arrow to the left, I don't start getting a y value. If I'm watching here, there's negative 0.9, no y value. Right past negative 1, I start getting a y value. So I'm going to guess that I'm going to have an x-intercept of negative 1. Now, that's without checking. If I do second calc, I'm getting reports and words. So left bound is there. Right bound, just go past it to where you have no y value, I guess.
That's what I did.
And then come back to a guess. And you get it's very close to negative 1, isn't it? But on the flip side, it's also going to be checked because it's not exactly negative 1, is it? And to be honest, I would have assumed negative 1. So I would have gotten it wrong if I would have just, taken a guess and left it there. And I'm checking. Yep. Now, that is negative 1.054 or negative 1.05. What do you think the other one's going to be?
Positive.
Positive. It does happen to be that. And you can see the symmetric properties here.
Yeah.
So if I do the 0 then, if I'm going to get over close to it, but before I get to it, right bound is after I get to it, and you have the positive. So actually, we could say plus or minus 1.054 or 1.05. I don't know why I almost said in 3 decimal places, but I did. Okay, and let's graph B real quick. While we're here, why not?
That's what I'm
I will say I'm preparing myself for 4th hour and saving them all so I don't have to retype them. I can't see. Is that 1.1?
Yeah.
It is? Okay, yeah. Yes. 1.1 x squared minus 65.4x. Oh, this is a fun one. 229.5, huh?
gonna zoom out.
Oh my god. Even is it? Oh my goodness.
This is gonna be
Okay. Does your graph look anything like my graph?
wow. Not
Now.
quite exactly.
And I'm on a standard zoom screen. So if yours doesn't look like mine, I would go to a standard zoom screen if you're trying to get it exactly like mine. Now, this is where, okay, so one thing I can show you, you don't have to go here with me. It's hard to tell what this is doing. If you go, I don't know if it's going to be good or bad. Option 0 is zoom fit. Sometimes I like it, sometimes I don't like it. So Sophie says I'm going to like it. Ooh, I do like that. So Zoom fit is something I like to try. Sometimes it is a huge fail and it doesn't make the graph look any better. Sometimes it really helps the graph look better. Now, what you'll notice is they are really zoomed out on that y-axis. You can't see the tick marks on the y-axis anymore. But remember, I have a 229.5 in this problem. That means my graph goes up to at least 229. Okay? So that's something to consider there. Now, so we find our solutions.
One more. I just found
How many do you think we're going to have?
Where's the Zoom fit button?
two.
Zoom fit is, it's option 0 on the Zoom list.
I have Zoom stat. What I do?
No, keep going.
No, keep going down. It's here.
Keep going past number 9.
Oh,
It's past number 9. It's Zoom 0.
got it.
Or just hit 0.
How many
Now,
guys?
if you're on this screen, you can still do, you can do second, calc, and 0. The left one's going to be the easy one to get. Takes me a bit to get over there. Left bound, right bound, and my guess. Oh, that's a nice one. What's your left 0? -9. I like that. How often do you get the nice, neat whole number option? Now,
Are there multiple on that one?
what's happening in the next section?
It's
Can you tell for sure? And here's the deal. Let me trace over there for you. I'm going to introduce another zoom option that I like to use in this case. But if I just trace over there, first of all, watch my my y value. It's at 8, it's at 5, it's at 3, it's at 1, 0.5, it's at 0. Oh wow, I just found one.
Yeah.
It's at 0.11. Okay, that's not really showing me what I need. It never showed going below 0, but here's the deal, guys. There are actually 2 zeros here. Are you going to be able to get those on this screen?
No.
No, because it's so zoomed out you can't tell. This is a perfect place for me to show you ZBox. So it's an option on your Zoom menu. So I would suggest you follow me here. ZBox. This is my Zoom menu. ZBox is number 1. ZBox is I draw a box around what I want to zoom in on, and so I'm getting to pick what I want to zoom in on. Okay? So if I hit ZBox, now, what I need to do is I need to position my cursor. I'm going to kind of position it off to the left because I want to draw a box around where it crosses the x-axis. So I'm going to hit Enter once I've got my cursor up in a corner. And then I'm going to go down and over. And as I go down and over, it creates a box. So you kind of have to pin the first corner, if you will. And then you go to the diagonal corner, and it creates a box as you go to the diagonal corner. And I'm going to hit Enter, and it's going to zoom in on just that part of the graph. And in all honesty, I feel like I'm still not zoomed in far enough. I mean, can I tell for sure it crosses the x-axis twice?
No.
Maybe, maybe not, right? So at this point, you can look at trace and see if we have a better idea. I do have a negative y values now, though. So that does tell me I have 2 x-intercepts. Could you use ZBox again? You actually can. You can ZBox again, so number 1. And this time, make a tight box. Stay close to those x-intercepts. If I go over and down there, and who knows?
Now you see it.
It's getting close. Mine's, I don't know, maybe I should have even gone in closer, but you can see that it is crossing, okay?
Yeah.
If I trace, again, I get negative y values in there. So that tells me that we are good. Okay, at some point you have to stop ZBoxing and find your zeros, right? Or just keep playing around in ZBox some more, whatever.
Trying to figure out.
That's the thing. Every time you zoom in a little bit more, it's going to get more and more precise.
Oh, there you go.
And see, now I've got mine zoomed in far enough that I can see it cutting down below, can't I?
Yes.
Now, that took me like 3 zooms. Had I just made a smaller box to begin with, it probably would have worked the first time, but you know.
The third time's the charm.
In my case, it is today. Okay, so I'm going to find my zeros. We know they're both going to be right around 5. So I'm going to go left bound is over there. Right bound, I want to go till I have a negative y value, so I make sure I'm past it. And the guess, is it exactly 5?
Yes.
Okay, so 1 is exactly 5. The other's got to be 5 point something then. Second, calc 0. This time, my left bound is when my y value is negative. Right bound is past it. Guess, I go back to the center. 5.1. So, the idea of hidden behavior here. Graph for failure, hidden behavior. Graph for failure, it's hard for the graph to get exactly, on that x-axis and whatnot. So on A, it's hard to know what's going to happen. On B, just glancing at it, could you have told me there was going to be 3 answers? Maybe, maybe not. Now, I'll tell you, I would have a guess there's 3 answers because my highest power is x to the third. X to the third means 3 total solutions, but it is not guaranteed that they are all real solutions. However, in this case, they were all real solutions. Okay? So, I wasn't going to finish all those, but I did. We're going to have to adjust my lesson plans, but that's all right. So, let's talk homework.